Good evening again. This is AKARSH Verma, and I'm going to walk you through quickly as to what Docker is and what role it plays in machine learning. And here's quickly the agenda for next 1 hour. We are going to talk about the problem effectively as to what I intend to share and why you guys should be listening me or why is this important, something like that. So roughly translates to about how do we deploy a machine learning model in production, because almost all of us are aware of different frameworks, they work on different tech stack, and we're going to talk about that. We'll touch quickly on Flask because that's one of the best ways probably to deploy machine learning models. It's also a very easy way. We'll look at some code and I'll quickly show you a demo where I have a Flask application which is running and support is picking a simple linear regression model. Something I picked off the internet, but it's a very good example. And then finally touching on Dockers and Dockerizing a Flask application and explaining you a couple of other stuff. All right. Questions are welcome. In the interest of time, I'll request let's probably it's 8:35 right now. We shall keep collecting questions and we'll look at questions probably at 9. 30 minutes or 25 minutes from now, depending on the number of questions, and then we can again look at them at the end. Okay.
Sure.
All right, guys. So let's begin. A little bit about myself, quick marketing stuff. So I'm Akash Verma. I'm an enterprise architect by profession. I am a statistician. I study statistics and I like maths in general. So that's where my interest for machine learning and deep learning comes. I am a tech enthusiast, so I do a lot of experiments, R&D, which is required both for machine learning and as a part of my profession. Feel free to connect me over LinkedIn. Would be happy to help out over and above the session. All right. Some important information before I begin. Whatever I talk in the next 1 hour is completely my view, and is based on understanding of the products. Things could have just changed. There are a lot of new versions of products and tools that keep coming out, and it's hard to be updated. And this is as latest as probably a month old. I'm sure Docker itself has released a couple of new features in the latest releases. So keep studying, keep upskilling. All right.
Akash,
Coming to the Mhm. Sure.
one initial question. How
Sure.
different is this deployment from TensorFlow serving?
Good point. Let me cover that. Let me touch on that. I have a slide specific to this. I will
Sure.
not address specific to the differences between TensorFlow serving because that's like a topic in itself. But I will talk about it. In any other question?
No, that's fine. Go ahead.
All right. So the problem definition. Now, as the question, let's start with the question itself. So TensorFlow serving is one of the approaches uh, for machine learning model deployment, right? And then there are a lot of other tools which I'll quickly showcase. Now, the problem effectively is for a large company is how many mechanisms do the developers or do the people in the company need to know to put their machine learning model in production. A lot of large scale companies, for guys in machine learning world, Python is the de facto language because people move to machine learning from different areas and Python is so easy to learn. But for large enterprises, Java is very common and popular. .NET is another popular framework, and explicitly making them talk with something in Python is kind of a hard problem. And the libraries themselves in, let's say, Java are not so popular as the ones in Python. So, and the community is also not so popular. Now, so the effective problem is how many mechanisms do we need to have to deploy our machine learning code in prod? And a larger problems for the company is if it's a distributed company with a large team. For startups, it's manageable. For small teams, which is effectively what machine learning teams are about right now. But as the size of the company grows, the approach or the unit of software needs to be standardized. which is effectively the problem that I'm going to talk about. Okay. Now, to touch upon, there are a couple of options when you want to deploy machine learning models. Uh, One option is we consume a provider API, which is usually powered by Python. And as you can see, you have Microsoft Cognitive Services, you have Amazon SageMaker, you also have something like from Google. Google has amazing vision and NLP APIs, which doesn't require effectively a new let's say model. You can bring your own model or bring your own data sets. It's very let's say uh, easy to use. You don't focus on the machine learning modeling part of it so much. You bring your data and you just do it. You just consume a third-party API. The other option is you made your own model, and you start with something like you have a model, you serialize it, and then you put a wrapper API around it using Flask. One option. Second option, TensorFlow serving. You have TensorFlow, then you have servable units, which you generate. You can either use Kubernetes to deploy it, or you can also deploy it using REST APIs. There's another popular framework called Celldown, which is similar to serving. I think I am not an expert in that, but that's one another option. One popular option which I personally like is Kubeflow, which is again something came from Kubernetes and Google World, but it is an end-to-end model. It's an end-to-end pipeline. There's a nice push around it, and it supports TensorFlow serving. It supports integration of different building blocks in the machine learning pipeline. So it's a whole end-to-end workflow management system. There's also something which is called an Apache Airflow, I think. Was it a Airflow? Yeah, it's I think Airflow, Apache Airflow, which also helps like workflow management in your machine model learning systems. But all of these are different tools to deploy your own machine learning model. And effectively, the problem that grows slowly within large companies is you really can't have all of them. If you have all of them, it's a maintenance nightmare. With because yeah, startups move fast, but if you have a model in production, you would want to have it being consumed for a business benefit. That's where this is coming from. So I know I'm not answering the question directly between TensorFlow serving and Docker's approach, but the point is that there are a lot of different things like TensorFlow serving, and effectively each of them have their own pros and cons. Yes, Docker has pros and cons, but it's a very standard way of managing software. In fact, it is not meant for machine learning. It's meant for any piece of software, right? So that's where this whole thought is coming from. So that's where I'll take a pause in terms of this and move on and quickly jump to a little bit of technical jargons. This is how, for people new to machine learn infrastructure, this is probably a full stack of software development. On the building blocks side, you have a easy to explain building blocks of the components, which I'll explain. On the left hand side are some very, very large problems for big companies. Effectively, architectural problems, infrastructural problems, and things like that. So I'm not going to focus much on the left hand side or the text, but rather on the right hand side, which is the stack. So if you look at the stack from bottom up, you have a server hardware, you have operating system on top of it, which is Linux OS or something, whatever Mac. And then on top of it, you have some sort of a virtual machine, typically Java virtual machine, or you can have some Windows runtime environments. And then you have an application server, which is Tomcat, VAS, or things like that. And for guys in Python, the equivalent is Django server or a Flask server. And then on top of it, you have custom configurations, probably your database connections, I don't know, your queues, your messages, different versions of the softwares that you run. And finally, at the final top, you have the server side deployable unit. Now, this stack comes at a lot of challenges. The most or simplest of the challenges is that maintaining each stack is difficult. Version upgrading is difficult because if you have something running in prod and you can't really change your Java version or upgrade your OS because of incompatibility issues and whatnot. But the point of putting this slide is that there's a lot of complexity involved when you deploy any piece of software. Machine learning is one another piece of software, right? Now, to simplify all of that, for machine learning, this is what you should remember. Your business problem, if it is a machine learning problem, boils down to two aspects. One is you consume a provider API or you build and deploy your API, which is what this talk is around, how to do the second one. Because I assume most of you guys are building machine learning models and do data cleansing and whatnot, and probably do that in your notebooks. So we'll move. So very quickly speaking, this is Vishal. Any questions by now, by the way?
No,
All right.
go ahead.
So this is a quick, again, this is a an image which I picked on the internet. It seemed very nice and accurate as to what I was thinking. Now, this is what is effectively comes within your environment. Let's start from the top. You can use a model training environment. It could be a Skykit based model, or it can be any model. It doesn't really matter. You if it varies in scenarios. For example, if you want to run your model on a mobile device, like you have a TensorFlow model and you want to run it on an Android device, you need to convert that TensorFlow model to a TensorFlow Lite model, and Google has a tool around it. I'm missing the name, and then that model effectively runs on the device. It's inferencing on the device. So, and for each kind for torch models, you have different approaches and things like that. But effectively, the idea is you have a model, you train it, and you put it in a binary format, or you put it in a format which is serialized effectively. The simplest or the most popular one is a pickle, but there are tons of other formats like Feather, HDFS formats, HTable formats, and whatnot. That's what you use for your saving the model file, a pickle, and then you predict using that, which is to say that if it was a linear regression I'm talking, I'll have a pickle file and I'll use that pickle file to make some predictions because that's what we want to do, right? To do that, we have some sort of an API which is written in Flask, and the whole goal of the Flask API is simply to provide you with an interface to talk to your model, because a model file effectively is just weights and balances for an equation, right? Now, so we have a Flask app, and then on top of it you have some components which is let's say really not so largely important. Okay, this is probably some standard stuff where you run an HTTP server and then you reroute your traffic using Nginx, which is a web app server kind of a thing, which your client can directly talk to. So the bottom layer is effectively just good architecture. We are just going to focus on effectively the first four blocks, which is the model training, save model file, model prediction, and the REST API. Okay. Now I'll
So
quickly.
one question,
Sure, sure, Vishal.
how do I run on the edge system?
Uh, I mean, the person who asked this, can you define what you are talking by edge? Are you talking on device like Android or iOS devices, or like IoT devices? I need to understand that first.
So he's saying no, probably typing something.
Okay.
On IIoT system, Industrial Internet of Things system.
Okay. So inferencing on IoT is something I am very less experienced with and have very limited understanding. So take it with a bunch of salt, pinch of salt. My understanding is restricted to the fact that on IoT devices we have protocols that behave or work with low network collectivity and low sizes. You have couple of architectures to do inferencing on edge device. One of the most simplest is that your edge devices are talking to a hub which has some kind of a compute power. because to do inferencing you need compute. It could be a Mobius kind of a thing like Intel Mobius or NVIDIA or something like that.
He's
So in a,
saying he's saying not on devices but edge servers which are collecting streaming values.
that's pretty much possible. If it's an edge server, see the whole point is for inferencing you need compute. If it is not edge, if it is the server, you can easily run it. Probably you are collecting a lot of streaming data from your sensors, like let's say cars or something. You can have models before that and you can feed that data into the model. One of the simple goal of the model could be, or it cannot be a model itself, it can just be the dimensionality reduction. If it is a server, you can do it. It's not really a problem, I guess. You would want to have a more larger discussion around this, because I can imagine it, but that's not the talk. So uh, we can discuss about it, but let's connect on LinkedIn and we can chat about it.
So he
But I
says, yes, they are
mhm.
servers, but how does it run every cycle of the fastest data?
Every cycle of the,
How does it run every cycle of the fastest data?
I don't really know what that means, every cycle of the fastest data.
So,
uh,
gentlemen, I would suggest you connect with Akarsh on LinkedIn. He
you
will be able to.
probably you can connect me on LinkedIn, because your problem seems to be well defined, and because you are chatting through Vishal to me, there's some loss of translation happening here. But if it is server, I assure you we can run inferences as well as any operation that you need. It's just how you we need to understand the architecture as to what is the component that is getting the data from servers. Probably you have some IoT hub like Azure IoT hub, or you have a Kafka server which is running. But it's very much possible to put in components that can
Kafka.
either do machine learning. Yeah,
He said
so
Kafka.
I would that's yeah, I was expecting it kind of. So if you have Kafka, then you can put your Kafka streams, channelize it, and put into other components. It's possible. There are a lot of things in Hadoop ecosystems. Let's chat offline. This will probably digress into a little bit in the big data and IoT side, and lesser on the let's say machine learning, specifically Docker side. But
Sure.
interesting question, sure. Sorry, buddy. Yeah, so I was just trying to show a demo, and let me do that first. Uh, so his what the heck? Okay, here is I let me just open a project which I'm running right now. So here's a simple Flask application. All right, I'll show you the app first. Vishal, my screen is visible, correct?
Yeah.
All right. So what you can see on my screen, localhost 5000, is a simple piece of code which I picked off internet. This is not my code, and I'm forgetting the guy's name to give the respects. This is simply running a linear regression behind the scene. So if you have 10 years of experience and you scored probably 100 in the test and your interview score was 98, this is predicting a salary. Okay, it's like a simple prediction, and you can keep changing it to a variety of parameters to get different numbers. The point is not to test the accuracy of the model or something, but it is actually predicting. How it is doing that? So this is the app which I have, and I'll quickly explain what we have here. Ignore the static and the templates. That's just basically the UI and the polishy things. Now this is the sample data, which is very simple. Okay, there's nothing here. It's just 10 records based on which there's a model which is trained. Okay. Now model.py is just a simple standard stuff where we are doing very simple things as converting strings to numbers and applying some lambda. But this is the ML part effectively. Line number 28 to 39, which says from linear regression, just create a regressor, fit it, do a transform, and dump it into Pickle file. When you dump it into a Pickle file, you can see there's a model.pkl file which is put it here. This is the pick serialized file. You can open the pickle file also. It will show you some crap. And this crap effectively has something which we understand, which is called D type, which means the data types, and it has some sort of a scalar, which should be, because effectively the coefficients of linear regressors are scalar. All right. So this is a model file which is just saving a model, a machine learning reading data, creating a machine learning model and saving it into a pickle file. Now let's go to app.py. App.py has a couple of interesting things. The first line is the first couple of lines is just creating probably an app for Flask, which is this is the default line. Second line is saying that, hey, pick this file, which is model file, and open it as a model. And then we are doing some predictions here, which is using model files and model properties. And this is rendered into the screen which I showed you. Okay. The requests file is just probably a simple it's just a Flask component. Now, the app file is there anything in the Docker file now? This is the app file, and that's the application which is running on using a sklearn machine learning model. So I'll go back to my cycle and explain. So we have the model training there, we have the pickle saving, we have the model saving prediction, sorry, and that is using Flask. And instead of a G Unicorn HTTP server, I have the Flask HTTP server, which is like a debugging server or a non-production server. Okay. This is where Flask is great. Okay. Now, any questions till this point in time before we jump on to the Docker's aspect of it?
Yeah, quite a few.
Oh, okay. Let's take them and probably, yeah, let's take them.
Sure. So first one is I need to automate the process of getting inferences from my given live data. Uh, Another is in continuation to that. I had it manually, but it mostly involves viewing graphs, statistics combined with my human domain knowledge, and then I came with insights and inferences. But I need to deploy this as a service. So need a brief idea about it.
Okay, so what I caught is that if I'm guessing it rightly, is that you are creating a machine learning model and you want to keep improving the model based on some sort of input from different data sources, and you are doing this manually and you want to automate that. Uh,
Right.
you can write a script, that's not really a problem. Thus, you can actually write a Flask app for this, which would effectively require something like a, for this specifically I would recommend you use Airflow, because Airflow has couple of good tools which allows you to connect to different data sources and read from there based on certain schedule
So
or an API.
So he says it is sort of data science project, like viewing graphs and getting insights, not specifically ML model.
See, if it is reading graph and generating insights, then you need humans. Uh, I mean that's effect. If it is understanding from graph, you need human beings, to the best of my understanding.
Okay.
I I mean, if you want to set some sort of a monitoring on graphs, like if my graph crosses certain threshold value, or if my time series has a upper control, lower control check, and it crosses some upper control limit, you can set up alerts and things like that and write services. But again, this is a problem which is best handled offline. Because again it would digress into non-Docker and non-ML related stuff. I'm sorry to put it that
Okay.
way.
Okay. Another one, does it always have to be a pickle file? You were just talking about pickle file on the
No,
slide.
no, it's not a perfect question. I'll show you data serialization formats in machine learning Comparison. I read a great article on Medium a lot of time back, or probably a paper. It is not Pickle is not the only option. If I find it, I'll probably we shall I'll share the literature at a later point in time. But there's a lot
Sure.
of options available, buddy. Pickle is not one. This is very popular. Apache Feather, as I have on the screen. Feather is a very nice binary column format. What else? Machine learning, Hadoop file format. I think that was H something. Uh,
So one gentleman is
yeah,
asking,
HDFS.
can't we use
This I will put.
ELK stack for getting data in modeling?
ELK stack has a. I mean, ELK stack is not meant for machine learning. ELK is Elasticsearch, Log, Stash, and Kibana. It's a whole together different problem area.
Okay.
It's basically logging and monitoring of infrastructure. Theoretically, if you have a search problem, which is effectively one of the things you do in machine learning, yes, you can, but there are a lot of options around it. I mean, why only ELK?
Okay.
I've pinged Vishal a couple of good references for this. There's one article which I have saved in my Medium, which is a excellent comparison of a lot of different binary formats. But to answer the question, Pickle is not the only one, but Pickle is by far the most used one, and there's a reason for that. It is basically a binary format. Lot of other format like you can actually store it in NumPy, also gives away, and Pandas also gives away. But all of these file formats are not compressed formats, and the model size will be very large. So Pickle is very efficient in that. Any other question?
So I'm sending your comments to audience. No more questions as of
Let's see.
now.
Let's see.
One question. What would be your deployment approach if the model also has to train in real time along with making inferences?
Huh. Can you repeat that?
What would be your deployment approach if the model also has to train in real time along with making references?
If you mean something like a deep learning network, RNN, I have not tried it, but this approach is effectively independent of that. I mean, you can still use Dockers. That's a very generic answer, I know, but you can, if your model is training continuously as you're inferencing whatever is the model type or the network, it needs a compute, effectively whatever needs a compute and a storage, you can do it with Dockers. Even when you run something in Google Colab, it's behind the scenes, they are spinning up a Docker image or a container image. It has nothing to do with the model network, the deep learning architecture, or the network architecture, or the machine learning library. You can still follow this approach, and it will still work. Oh, this
Okay,
is not the example. I mean, if you guys disagree, just again ping me on LinkedIn or somewhere. All right,
go ahead.
I'll jump to Docker because we have almost 9 o'clock, and I want to really
Sure,
continue on this.
let's take questions towards the end now.
Yep. All right. Now, quickly jumping onto the Docker, and the goal simply is to show you a Flask application which is Dockerized, and then show you a couple of other cool stuff. Uh, this is an important slide. So let's and probably disconnected. It is generic computing. All right. So on your left hand side, which is this. You have a diagram which explains how virtual machines work. This has absolutely nothing to do with machine learning. It has to do with how softwares run. It could be any software. It could be Python. Python is also a piece of software. Okay. So on the left hand side, you have a building block, and on the right hand side, you have another. Let's see what is the difference. Infrastructure is common in both, but on the left hand side, you have something called as an hypervisor, which you can imagine to be like a virtual box on your machine. Okay. It effectively does what it does is, let's say you have a physical machine of 12 GB, it will chunk out your memory or and your CPU and your storage into three parts in this diagram. Each can have their own operating system, and each will have the fixed amount of memory, RAM, and storage. Sorry, CPU, RAM, and storage which you allocated. So if anybody has run a virtual box on their Windows machine and tried to run Linux inside it, this is exactly that. On the other hand, you do not have anything like a hypervisor. You have something called as a Docker engine or a container engine, where you just focus on your app. In the first option, you have three different operating system, and each operating system consumes some memory and infrastructure, and also the slicing that you allocate to each of the box is kind of a fixed. So even if your app A, B, and C are all of them are sitting idle, and suddenly only app B is running, app B will only get 4 GB of memory, and even if the rest of the 8 GB is free. But in the right scenario, if your app A is running and others are dormant, like not dormant, low memory consuming, it will expand to consume more memory. It's like a difference of fixed memory versus shared memory. That's the idea. Okay. uh, it will come and become a little more clear in this diagram. Traditionally what happens is, whatever you do, whatever you have operating system, you have Java, your Python, your databases inside that, and then you build applications on top of it. In a containerized environment, what happens is that you simply package all of the things that you need or that your software needs into a unit, and it just runs. When I say it runs, it will run anywhere, everywhere where there is Docker. So all of us were in our colleges studied like Java, write once, run everywhere. That doesn't really happen. It needs a lot of configurations, or at least some configuration. With Dockers, the mantra is you build once and it will run anywhere, wherever Docker exists. That's all. So the way it does is, it packages every damn thing inside a bundle, and that bundle is running. Some Okay, maybe I'll show this and then explain the commands. How do you Dockerize an application, or how do you make your application Docker compatible? It's very simple. You develop your app, you write your application, you code it. Then you write a something called as a Docker file, which is simply the details that you tell Docker that, hey Docker, my software needs these things to run. It could need Flask, it could need TensorFlow, it could need your notebook server, it could need a lab server. All of that you tell it and it will download. Think of it as like Play Store or of a kind of a scenario. And once you write a Docker file, you build it and you create your own bundled software. It will run anywhere. That's what it effectively does. Commands are really simple. You do a Docker build, it will build. You do an images, it will image, and it's straight up. Run, it will do run an image. PS will list, stop will stop, RM will delete. It's very simple. These are the all the commands that you need to know. Now, some terminology I'm skipping this in the interest of time because I'm hoping for questions. But I can share the slides later. A simple workflow. What is important to understand in Docker is there's a tool, or let's say a platform called Docker Hub. I'll show that now. On Docker Hub, you can find instances of all the things that you need. You can find Python, you can, like you see, Python is present here. You can say Jupyter. It will have all kind of Jupyter notebooks and things like that. Whatever you need, it will be available here. All right. Now, so that's what a Docker Hub is. It's like a play store for your all Docker images. How does this work? Let's say on the left hand side, it's your machine and your own code. You write a Docker file, you use the Docker engine in the green here, and you build it, and you come up with something called as a container A. A container is just your bundled software. You push it, you push it to like a Docker Hub if you want to share it. This is very similar to Git, concept wise, not like functionality wise. You push your hub Docker image into the Docker Hub, and then anybody else in the world can just download it, or which is like a pull, and run it on their machine. Okay, this is a simple workflow for Docker. At the end of slides, I have certain appendixes which are like a little advanced for this session. But if anybody is interested, feel free to look into that and ask me questions. I will quickly jump on to my next demo, which is showing a Dockerized Flask application. No, this is not it. This is it. And I will need. Oh, one second. I should. Just give me a moment, guys. This is, yes. Okay, images. Yeah, so let's see. So this is again a simple Dockerized application, which is a much smaller Flask application. But the idea is I just showed you a Flask application which has machine learning integrated with it. This demo is just focused on showing a Flask application which is running in a Dockerized mode using a Docker file. So my application just needs two things in the requirements, Flask and Redis. So I'll write a Docker file which will say my runtime is Python, okay, which will be from Python. Then it will set my working directory. Then it will copy my app code. And then inside the container, it's going to run the pip command and expose a port which is useful to run this application. Okay. Now, if I go here and say docker build dot, it will do couple of steps which are effectively, as you can see, 7 steps here. It will do 7 steps here, right? It is building a complete container image from scratch, but as I had a pre-built instance here, which is the hello world, I'll show you what it does. And just quickly run it. Where the heck it go? So this application doesn't do anything. It's just a hello world. All right. Should go to what port? One second. 4000. Yeah. See, so there's a hello world running right now, and this is just connected to this console right now. Now, what you have to understand and realize is that the demo that I showed before, Flask, it was using my system's Flask, which is the Flask and the Python, which is installed on my Windows machine. In this scenario, in what I'm showing you right now, everything is picked from here. You see the 928 MB, everything is inside this. So right now, if I uninstall everything in my machine, or if I give this to somebody who's using Mac and a brand new laptop, and the guy just downloads Docker and pulls this image, this application would work the same way as it is working here. That's the whole point of Docker. So you build your software in such a way that all of your libraries, all of your configuration, all the needs and necessities are packaged inside a unit of software which is easy to ship and it will run everywhere. That's effectively the essence of Docker. Now, the way it does is these things is using couple of Linux level features, which are part of the appendix, which you guys can see. I'll quickly try and explain this image as to what happens. So imagine this stack, as you can see, and start reading this from the top. The first line says from Ubuntu. So first Ubuntu will be created. Then it says run curl download JDK, right? It will use CURL to download this JDK. Then it will run that, which is again couple of things in the stack. Then it will again download few things and run it, and that's the next things in the stack. Then it will expose a port here, which is this, and then finally you define an entry point. So these couple of lines give you a Docker image for some specific software, which is Jenkins in this case. In the example that I showed, which is this, here we are making a Flask application. How? I'm simply giving Flask in my requirements file and I'm telling it to use Python base library. Python itself could have used Ubuntu. We don't care because all my application needs is Python. That's effectively what a Dockerized environment is and what Docker does. There are a couple of really good to have things in Python. Like if I open this, you can have a notebook server anywhere without, let's say, you have a work machine and you don't have permissions to install Python. Hey, whatever, or you whatever. This can give you a notebook server completely on your machine. So this will run Jupyter Notebook inside a Dockerized environment, which is what I something have here. As you can see, Jupyter minimal notebook 2.6 GB. This is has everything that Jupyter needs to run, probably Python, the libraries, the dependencies, and you can add more things inside it like you install in any other machine. So that's effectively the summary or the talk which I wanted to have. I guess I should thank you guys first, and let's take questions. Vishal, over to you if you have questions, or if somebody wants to have a question in demo or code. Let's see that.
Right. So,
Or if you want me to repeat something, I'm glad to do it. We have some time right now left.
I'm just seeing if I left any question, although I asked. I knew them. Mm. In ML, you will need to infer the patterns of chart for predictions too. That's what the statement had come. I don't see any other questions.
Uh,
Guys, if you have any questions, please ask now. So this video would be released in 2-3 days time on our Selfstat YouTube channel. I have already given the YouTube link. This and
mhm.
many others, and probably more future ones coming from AKARSH will be released there. Can
Yep. So,
you talk about Docker network?
Docker network. I'm not sure if that's something. Let me see if you guys mean Docker Swarm or Kubernetes. Docker network. I've never heard of the term in general. What is a Docker network? Okay, it says Docker net supports networking using network drivers. Buddy, I don't really know what a Docker network is, but if you are trying to understand how multiple containers work together, the answer to that is one, Docker Swarm, or use Kubernetes, which is designed to do this. Or if you are trying to understand about networking, absolutely possible. I'll quickly show something in my slides. There's a if you see the Docker engine, this is a very summarized view. The Docker engine is effectively that layer which takes care of the heavy lifting of build once run anywhere. It is what manages your calls and all type of calls, which is your network calls, your port request, your IP requests, your whatever, your hardware request, memory compute. All of that is taken care by the Docker engine. And inside the Docker engine, there's a specific component building block, which is networking, which takes care of the network related stuff for individual container. For multiple containers, it is managed through either a Docker Swarm, which is the master node, or it can be managed through Kubernetes also. But
Okay,
again, a very simple answer.
a question in succession to that. How can we make 2 or 3 Docker containers communicate? Will there be an option to create a complete standalone package?
So that's what I said. So if you want to have multiple containers talking to each other, one, if they're talking for application level use, which is some functionality like data exchange, or probably one container is getting the data and reading the data from a database, and it is passing to the next container for, let's say, machine learning model, which is further passing a pickle file to a third container. Then you should do this using some sort of a programming interface like an API or something, not REST API, but still an API. If you want to just have some data which these three containers share in terms of networking, software networking, then Docker Swarm or Kubernetes is a better way. Or you can put them in a virtual network and it will work. It depends on where you have deployed it. One, uh, it effectively depends on where you have deployed it. There's no second to that. Like in my machine, I can show you that I have like too many. I have like one, two, three, four, five, six, probably 10 containers, each of them doing different things. Some of them are like months old and some of them are new. Like the Python one
So,
is not updated for 6 weeks.
okay. Is Kubernetes an alternative to Docker? If there is any difference, please explain.
It is not an alternative to Docker. See, Docker effectively solves one single problem. It is which is running in one environment. Now that you have packaged your software in such a way that it can run once, you need to run multiple containers for supporting multiple user load. Example, let's say you deployed a Flask API, okay? You had a pickle file which was stored on disk, and you deployed a Flask API which is reading from that pickle file, let's say C drive somewhere of some machine, and exposing an API in one container. Now, if you want to run multiple, like 10 containers, which is doing the same thing, like load balancing scenario, you need some sort of an architecture, which has nothing to do with machine learning specifically. It's an architecture, software architecture. There, Kubernetes can be used, or Docker Swarm can be used. That's the answer. It's not which is better, it's the scalability. If you want to run one, you run Docker alone, great, your own machine. If you want to run the container instances for your entire company, you need Kubernetes or something like that. It's a whole container management system. It's a whole topic in altogether. I mean,
Okay.
much. I had few slides of it, but I removed it because it's the architecture is very different, and it has nothing to do with ML.
Okay. In extension to current question, want Nginx container to communicate with Python container and that with SQL container. Can this be achieved with Docker Swarm?
Okay. First, yes, it can be. Second, Swarm specifically is not doing anything here. Swarm is just controlling the three containers. The connectivity is something you define and manage. Swarm is just helping you expose port, interchange port, and things like that. But possible. However, if this is your landscape and scenario, I will strongly advise you to not put a database inside a container. It's it's not that it cannot be done, but it is a wrong design practice. Databases should be given dedicated, should be kept as close to physical infra as possible for various reasons. Certainly deploy your Nginx in a container works amazing, easily available on Docker Hub. In fact, it has highest stars or probably top 10, something like that. And then your Flask application could be the second, which the Nginx routes to. And then the Flask app should talk to a database, which is like a full database, a real database, not like a containerized database. Why am I recommending this? Because see, containers are great, but running containers inside, uh, running databases inside container leads to certain drawbacks because containers are prone to, let's say, not prone to, are designed to be auto healing, or let's say they can restart automatically if something happens. But you don't want your DB server to restart and your all data to be lost. You can still achieve it, but needs a much more dedicated architecture. I'm sorry for the long answer.
Uh, One last question is here: is a
Yeah.
Docker image portable? Can the image be
Yeah.
exported as well?
Yeah, it's absolutely portable. See, this is what is Docker Hub is where you port it, right? Docker Hub is the place store for all your images. Like I'll show you quickly. Maybe I might not have an image because I never push anything here. So this is my account, and you can go to my content, and you should see create or manage private repository plan. You can keep stuff from your side as much as you want. Let's see if I have actually something. No, so I don't have a repository at all. So I can create one, and it'll allow me to store all kind of container images here, and I can share it with anybody I want. If it is public or if it is private, then I'll have to give some key and blah blah. But it's very simple. It's just these two commands. You tag
Okay.
it and you push it. It's simple. It's very, very simple.
Okay. For my
Anything else?
Flask, for my Flask
Mhm.
Docker image to be portable, should it be uploaded to a Docker Hub?
No. Uh, so the answer is if your Flask, if you if your Flask app is portable, meaning it's containerized, it is containerized. See, understand this. When you containerize something, it's just packaging the software. It's like a zip file, okay, which has everything. It's not a zip file, but it's like a packaging way. It has everything your software needs to run. So if you only want to run on your machine, still will work. But if you want to share it with other people, just push it to Docker Hub, and the other guy will do a pull, and it will still work the same way as it works on your machine. So nothing like मेरे system में नहीं चल रहा है, तुम्हारे में चल रहा है, whatever, something like. So it's always portable. The moment you containerize something, it is always portable. Yeah, the size of the container is a conversation. It could be very small or big, but yeah, what the heck? The internet is nowadays very fast. Any more questions?
So next question to that, I want to use the container on a different machine. So this is an extension to the previous question.
Yeah, yeah.
Should it be uploaded to Docker Hub?
It
And I want to use the container on a different machine.
yes and yes, which means if I have a Windows machine and you have a Linux machine, and I have created a Docker image in the right way, and it is running on my machine, and then I upload to Docker Hub and you pick it to run on Linux or Mac, it will work. It should work. If it is not working, then the problem is the in the way we have not configured it correctly. It always work. I mean, just look at Docker Hub and you'll realize what pieces of software are is available as a like. Just look at this, probably the small image. It says Docker pull Ubuntu and two lines. These two lines itself will give you entire Ubuntu from Docker Hub. So whatever we write, I'm pretty sure it's not complex as Ubuntu is. And as you can see, there's every Nginx available and things like that. Okay, any more questions?
So does Dockerization help for blue-green deployment?
Uh, See, blue green AB is a deployment strategy. Uh, how do I put it? Dockerization would certainly simplify and ease it. It's really not directly doing it. You can manage blue greens, but blue green is a little more different thing than this. You should, I mean, Dockerization would simplify it. It will make it faster, certainly. I can imagine that, probably.
Okay. Uh, what's the OS within a container?
Okay. Let's see. I'm not 100% on sure, but I think it's Alpine, because Alpine is like a 4 MB Linux distribution. If I'm not wrong, there are a couple of other components inside a container like container D. No, strong word, wrong word. One second. Which is a container runtime environment, which could possibly also have a OS itself. To the best of my understanding, this is Alpine works, but it really depends on what the provider is giving. If you are running probably on Azure, I don't know off the top of my head. I think it's CentOS or something, but it doesn't really matter, honestly. Certainly not
Okay.
Windows, by the way, as far as I know. That I can say,
Okay.
because it's based on Linux technology. Could be wrong, as I put a disclaimer before.
Okay. So is it better to run a ETL task in Python or via Airflow or Dockerize it?
Wow. ETL task on Python or Airflow? Okay, Airflow is workflow management, so that's out. It's a tricky question. How much data do you have? If see, Python as a language itself, as you might have heard, is scalable to a point. So if you're talking megabytes and gigabytes of data, you can do it in Python or any other language. But if you're talking terabytes and petabytes of data, then you are better off with Hadoop platform. And even there, you can use Python. You probably will be stuck with something like a PySpark or something. I don't really know exactly for ETL.
Okay. Any other questions, guys? So we have a Disrupt 4.0 group on WhatsApp as well. If anybody would like to be part of it, we share a lot of content there, and we have AI lab sessions happening in Gurgaon and Bangalore. Where also in Gurgaon, Akash speaks very frequently, and a lot of other speakers. In Bangalore, we have a lot of deep tech researchers who present off and on. So, although you are giving me a number on the chat, I'll share my number in a few moments, or I'll share it right away on the chat. You will have to drop me a message. I cannot just add anybody. It has to come from you. Uh,
Alrighty.
So, any other questions from Akash? He's still online and he would be able to respond, although we are 2 minutes ahead of time.
Yep. I mean, feel free
So,
to connect. This is like great stuff that Vishal and Vivek manage, and let's just support them. Let's connect over LinkedIn. If you guys have specific use cases, would be happy to. Uh, let's.
Akash, would you like to share your contact details on chat if you would like to? or if
Yeah,
you would
sure.
like it to route it through us.
That's fine. Just give me a moment. I'll give people my LinkedIn. I see some invites from LinkedIn, but just give me
Great.
one moment. Uh, LinkedIn is loading. What the heck? Yeah, this is it. So, guys, connect me on LinkedIn. That's the best place to. So this is me. Don't look at my tests. I probably failed a few. You can look at other stuff. This is me. Probably look at the picture. It's the same one which I showed. That's the only picture I have which makes me look okay. So let's connect on LinkedIn. I see a couple of invites. Feel free to share personal experiences or challenges that you guys have or use cases. Would be happy to collaborate on anything. At least learn if I may not help, as this is more like a co-learning and collective learning.
Great.
Alrighty, if that's all, shall we disconnect and have food,
Yeah.
everyone?
So
Right.
thank you for your time, Akash. It was
No,
very
no
good,
worries.
and I hope
No worries,
everybody
Vishal.
liked it too.
Yep, I
So
hope so. Feedbacks are very much welcome, guys. Feel free to send it to me directly or to Vishal. I'll change everything that is needed. And if I need to change my style, I can do that too. I'm also learning. So, good night. Have great food. Bye bye.
bye.